Hello everybody. Last class we started with the structure of atom. I told in the beginning of the session, beginning of this particular chapter, that structure of atom, whatever concept we had, we have to change the concept little bit. Okay, we have to de-learn and relearn the concept. Anyway, so first class we had talked about the basic things which you had already know. We had talked about the discovery of electrons, discovery of protons, discovery of neutrons, then how the atoms were actually told that how is the shape of it by two theories actually. One is Thomson's resin pudding model or watermelon model, and the second one is what? The second one is Rutherford's model. Rutherford did it by some experiment. Now before going to Bohr's model, some other information we must know, then only we can move to the Bohr's model. We cannot go straight away to the Bohr's model. The first of them is electromagnetic radiation. Please understand these things. Electromagnetic radiation. Electromagnetic radiations. Okay, electromagnetic radiations. This is actually coming from a classical theory. Okay, there are two theories in physics actually, two theories in this complete physical thing. One is classical theory, another one is quantum theory, which explains everything of the atom, everything about the structure of an atom. So electromagnetic radiation, according to the classical theory, is what? It's a continuous wave. It's a continuous wave. But it's not any wave, it's a continuous wave. Okay? The direction of the direction of the wave, okay? Whatever is the direction, first of all, this wave generates two fields. One is electric field, another one is magnetic field. Electric field and magnetic field. That is why this is known as electromagnetic radiation. This is the direction where the propagation I am writing. This is the direction where the wave is going. It is generating an electric field, it is generating a magnetic field. Okay? And if the electric field, magnetic field and propagation of the wave are perpendicular to each other, suppose this is x-axis, y-axis and z-axis, they are perpendicular to each other, then that particular wave, that particular radiation is called electromagnetic radiation. That particular radiation is known as electromagnetic radiation. So electromagnetic radiation is what? It's a continuous wave which is responsible for the generation of electric field and magnetic field, and the propagation of the electromagnetic wave. The electric field, obviously a vector quantity, and magnetic field, another vector quantity, are perpendicular to each other. They are all perpendicular to each other. Then that particular radiation is known as electromagnetic radiation. Now this is a big term. Electromagnetic radiations can be of different types. It is characterized in different types. This light that is coming is an electromagnetic radiation. That is visible light. Okay? The microwave, which you see, the microwave, all of us are using nowadays the microwave oven. So microwave is also an electromagnetic radiation. The radio wave, the television wave, the X-rays, okay, the X-rays, the ultraviolet ray, the infrared, etc. There are so many are all what? All kind of electromagnetic radiation. Only one thing is common in them, you know. All this electromagnetic radiation has one thing in common, and that common thing is that they all move. This electromagnetic radiation move with the velocity of light, and that is equal to how much? 3 into 10 to the power 8 meter per second. Okay? That how they are differentiating? How do we know that this is a visible light, this is a microwave, this is some IR, this is UV, or this is radio wave, or this is long radio wave? Some is FM, some is AM, FM radio, AM radio. Why? How they are differentiated between each other? They are characterized, they are differentiated in terms of two things, you can say basically, okay, which you must understand, okay, two things, okay, two physical properties you can say. One we call wavelength. See, this is moving with, this is the electromagnetic radiation, suppose, moving with a velocity of light, I am drawing another electromagnetic radiation like this, which is also moving with a velocity of light. This is also a continuous wave and is responsible for the generation of its electric field and magnetic field and moving with the constant, the speed of the light and the propagation of the wave. The electric field and the magnetic field are perpendicular to each other. Now, how they are varying? How they are varying? Both have the same speed. They are varying in terms of their wavelength. First of all, first term, they are varying in terms of their wavelength. What is wavelength? That is denoted by, first of all, that is denoted by lambda. Lambda, we call it lambda. Okay, lambda. Lambda. Okay, that is the first thing. Okay, what is the wavelength? It's nothing. It's the difference between the distance between the same phase, same condition. Phase means condition. Same condition of two successive waves. This is a wave, this is another wave, this is the peak of the wave, this is the peak of the wave. The distance between the two successive peaks or two successive lows, okay, is called the wavelength. So here, what is the wavelength? Here the wavelength is this one. This much is the wavelength. So are they differing in terms of their wavelength? Here the wavelength is more, here the wavelength is less. So all these, whichever I told as the electromagnetic radiations, are having different wavelengths. Depending on their wavelengths, they are showing different properties. Okay, and hence they are differentiated in different names, like as I told, ultraviolet, visible, this, that, so many others. Okay, radio wave, television wave, etc., 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 etc. Okay, that's lambda. The second term by which you can differentiate them, you must understand this. It's not that you should remember it. That is called frequency. Frequency, which is denoted by nu. We call it nu. Okay, frequency. Now, what is frequency? Please understand it. This wave is coming with the speed of light. This wave is also coming with the speed of light. Fine? Okay? They are coming with the speed of light. Obviously, where the wavelength is more, the first one the wavelength is more, the second one the wavelength is less. Now, we have some space over here, some instrument over here through which these waves are passing. Okay? Fine? And through this instrument we can see. Suppose we can see through these instruments. And we can count the number of waves. When the first wave is going with the speed of light, suppose, or with any speed, frequency can be applicable for anything. In this particular case, it is going with the speed of light. Okay? Now, concept of frequency does not need the speed of light. Suppose some waves are going. You are observing from here, you are counting the waves, and you have counted that how many waves are passing this particular place, particular point in 1 second. You counted it. Suppose in 1 second, this wave passed 50 of these waves is passed in 1 second. 50 waves are passing at this particular place in 1 second, you counted it. Okay, 50 waves. Fine. The next wave, the second wave is also moving with the same speed. As this was moving, this is also moving with the same speed. Clear? You are counting this also. Can you say that in 1 second, will the number of waves in this particular case is more or less or equal? Yes. So you can very easily say, it can come in your mind that, sir, it will be number of this will be more. Why number of this will be more? Because the chota wave, these are small waves. That is why more number of waves will go out in a particular time. Yes, you are correct. That is what is frequency. Frequency is what? The number of waves that is passing a particular point in 1 second. Per second, how many waves are passing? Okay? So the unit of this will be per second. Whatever, some number per second, or you can write second inverse. Okay? Second inverse. The unit of wavelength will be what? That's nothing but a length. So SI unit will be simply meter. Okay? You can denote it by any other unit, picometer, nanometer, centimeter, whatever. But the SI unit of this will be meter. But what will be the unit of frequency? The unit of frequency will be second inverse. Hope you understood that the number of waves passing a particular point in 1 second is called the frequency. Okay? And you told me that you understood that also. So since this wave is smaller, its frequency will be higher. Yes. So can we say that wavelength is inversely proportional to the frequency? That means more the wavelength, less is the frequency, or less the wavelength, more is the frequency? Less the wavelength, more is the frequency. So the relationship between lambda and nu is lambda is inversely proportional to nu, and that is equal to, for electromagnetic radiation, lambda should be equal to this constant. The proportionality constant is nothing but the velocity of light divided by nu. So that is the relationship between lambda and nu. And the unit for nu is what? Unit for frequency is what? Second inverse, and that was actually observed, actually given by a scientist called Hertz, and hence the second inverse is also known as Hertz, and we denote it by Hz. Okay, you had heard about it in FM radio. All of you have heard 93.5 Hertz or 93.5 megahertz. Hertz is the unit of what? Unit of frequency. Unit of frequency. Simply unit of frequency. Okay, which tells us about the nature of the wave. That what wave is it? Yes, just by saying the frequency range, we can say this particular wave is because of microwave. This is IR. This is visible. This is that. This is that. We can say that. Okay. And another term is there. Another term is there by which also we can measure or we can differentiate between the electromagnetic radiations, but that is not very frequently used. That is used very rarely. That is called wave number. The third one is called wave number. Wave number, which is denoted by nu bar. Okay, we denote it by nu bar. It's nothing but the reciprocal of the wavelength. It's nothing but the reciprocal of the wavelength. Simply, it does not have any physical concept. It's just a mathematical concept. And wave number is nothing but a reciprocal of wavelength. So obviously, its unit will be 1 by meter means what? Its unit will be meter inverse. That's just a mathematical concept. Okay. So more the wave number, less is the wavelength. More the wave number, less is the wavelength. That is just a reciprocal of wavelength. That's all. So that is all about electromagnetic radiation. Now we will do today one numerical, and then we will stop. Then we will move forward further next class. First, let us do this numerical so that the concept of electromagnetic radiation will be clear to you. Just to write it, that if the wavelength of a street light, okay, just arbitrarily I am giving, street light is 589 nanometer. 589 nanometer. Calculate its frequency and wave number. Calculate its frequency and wave number. Okay, so that's the question. So obviously this is the electromagnetic radiation. Straight light means the visible light. That's the electromagnetic radiation, and it is moving with the velocity of light. What is given now? Given is the wavelength. That is lambda is given. Lambda is equal to how much it is given? 589 nanometer. Now you must know the relationship between this. Okay, that I am writing here. You must know this. 1 nanometer equal to 10 to the power minus 9 meter. 1 picometer equal to 10 to the power minus 12 meter. 10 to the power minus 12 meter. 1 angstrom equal to 10 to the power minus 6 meter. 10 to the power minus 6 meter. Okay, so you must know this. These terms you must know. Okay, because it's very often used. Very often used these terms. Okay, so you must know this. So lambda is equal to 589 nanometer. So obviously, since we are going to use this in the SI unit, we must now convert this into meters. So that is equal to 589 into 10 to the power minus 9 meter. So that is equal to, can I write 5.89? I'm just making the decimal point over here, into 10 to the power minus 7 meter. Okay, so that is lambda. That is lambda. That is given. what you have to find out? You have to find out nu and you have to find out nu bar, right? Is that the question? That you have to find out frequency and you have to find out the wave number. So frequency is equal to what? Let us do in that side. Frequency is equal to what? We already know what is frequency. Frequency equal to C by lambda. We know this. Frequency nu is equal to C by lambda. So that is equal to C means how much? 3 into 10 to the power 8, right? Divided by 5.89 into 10 to the power minus 7. This much what? This much hertz you can write. This much second inverse you can write. You can calculate it very easily. Okay, so that is 3 divided by 5.89 into 10 to the power 15, right? Okay, so if I just take it almost around 6, just I am taking the approximation almost around 6, don't take it, you can calculate it also. Okay, so if we take it 6, it is 1 by 2, 1 by 2 means 0.5, okay, so can I write almost equal to 5 into 10 to the power 14, almost the value will be almost equal to 5 into 10 to the power 14 hertz, but you must do it very correctly, okay, that is the value of nu, and what is nu bar? Nu bar is equal to 1 by lambda. What is lambda? Lambda is equal to 1 by 5.89 into 10 to the power minus 7. So that is equal to 10 to the power 7 divided by 5.89. So that is equal to, you can write 10 divided by 5.89, just one division you can do, into 10 to the power 6. That much what? 1 by lambda means what? That is meter inverse. Is it clear? Okay, so like that, any question you can do. So hopefully you understood that what is electromagnetic radiation, the basic part of it. As I told, we are going to go very slow, but you must understand the thing. So what is electromagnetic radiation? We understood. That's the radiation which is responsible for the generation of electric field as well as the magnetic field, and the propagation of the wave. The electric field and the magnetic field are perpendicular to each other, and this is obviously a continuous wave. Okay. Now, there are different types of electromagnetic radiation, but one thing is common in them. The common thing is that they all move in the velocity of light. How they are differentiated then? They are differentiated in terms of their wavelength. What is wavelength? The distance between the two successive similar phases. Okay, similar phases. What is frequency? The another term, frequency. What is frequency? The number of waves that is passing a particular place in a particular unit in 1 second. In 1 second, how many waves are passing out? That is what is frequency, and that is given by second inverse or hertz. And what is wave number? Wave number is nothing but the reciprocal of lambda, reciprocal of wavelength. Okay. So hope you understood that. Till electromagnetic radiation, that will be there today. Then tomorrow we are going to start with the next thing. Thank you so much. Stay safe, stay healthy.